Hello and welcome to this tutorial on using the SG90 servo motor with an Arduino. In this video, we'll show you how to use a for loop to control the position of the servo motor and create a simple sweeping motion. A servo motor is a type of motor that can rotate to a specific angle and hold its position. They are used in many devices that require precise movement control, like robots, remote control cars, and airplanes. Unlike regular motors, servos stop at a specific position and can be controlled using signals that adjust their position. The servo motor has 3 wires and they are brown, red and orange. The brown wire is used to make a ground connection and the red wire is used to power the motor and it is in 5 volt. And the orange is used to make a PWM signal through the wire.
Okay, so now we'll establish the connection between Arduino and the servo motor, but what is to be remembered here is we can directly connect the servo motor to the Arduino. For this we need to use 3 extra male-to-male jumper wires. Connect the matching the colors. We need to remember that the orange one is the PWM signal cable, and according to the code, we'll connect it to the 9 digital pin of the Arduino board. Here we go. And the red one is a voltage cable, so let's connect it to the 5 volt port. And we'll establish the ground using the brown wire. Here we are done. So here is the explanation of the code we have written. First, we need to use a library file which is named as servo.h. This just to make our things easier. Then we have to create an object. In this case, we have named this object as my servo. You can use anything you want. In the setup function, we need to specify the PWM pin we are going to use. Just to let you know, there are a total of 6 PWM pins on the Arduino Uno board, and they are 3, 5, 6, 9, 10 and 11. In this case we have used the 9th digital pin, as you can see right here. In the loop function there are 2 definite for loop we have used. The first for loop, what this is doing is it is rotating the servo from initial position 0 to final position 180, and we have used a step of 10 degrees here. And after this operation is complete, a delay of half second or 500 milliseconds is introduced, and the second for loop, what it does is it does exactly the opposite that the first one has done, and this is the end of the code. As you can see, according to the code we have written in Arduino ID, the servo is spinning from its initial position. It starts from its initial position 0 and then keeps adding 10 degrees to its specific rotation as the for loop keeps running. And then it finalizes its position to 180, and when it comes to backing up from 180 to initial position 0, it does exactly the opposite.